today's lesson is z-scores. Now, we can transform any normal distribution into a standard normal distribution by using z-scores. What that really means, I just want to show you how useful and how wonderful z-scores can be. This is Miss Yen's scores, raw marks of English, Math, Science when she was at high school. I don't know. Now, this is the formula that we have to use. I want to know which subject I did better. It looks like, a bunch of numbers, raw marks to me, but how am I going to sort of compare? I mean, how can you compare? Like English, Maths, and Science, they're all sort of different, but z-scores can do that for you. So let's have a look. So these raw marks are the marks that I've got. The total out of something, it doesn't really matter. So 60 out of, 70, 60 out of 100, 60 out of 90 doesn't really matter for English because it'll translate it and compare it in a 3 simple ways, like above the mean, 0, below the mean. That's what z-scores do, okay? So you throw everything different distributions and z-scores somehow magically put it into the 3 levels, above the mean, below the mean, okay? So that's why it's quite useful. So let's have a look at this. So I'm going to change this to the z-score so that I know how far my raw mark is below or above or even the mean, okay? So I've got X is my, I'm just using this formula right now, okay, here. X is my raw mark for English is a 60 minus my mean, the average, 42. And then I need to divide it by standard deviation because it's like how many standard deviations from the mean. So obviously you need to divide it by that, okay? So it's 10. So when you put that in your calculator, you'll get 1.80. And I want it to be 2 decimal places. It's good to have 2 decimal places. And then the maths. Okay, my raw mark was 45 and my the average, the mean is 28 and my standard deviation is 6.8 and I put that in, I'll get 2.50. And for my science, I've got 53 take away 40 all over 7.4 and put it in your calculator, you will get 1.76. Now you can see why I said 2 decimal places, isn't it? Because if you look at my English z-score and then science, if I had 1 decimal place, it probably will be the same. So I don't know which one I did slightly better or not. It's very close, but I can see that English is 1.8 away from the above the mean, okay? And then science is 1.76 above the mean. Mean here is 0, obviously. Now, as you can see, we didn't know which sub I did better when I'm just looking at the raw marks. But with converting it to z-score, I can tell where they are at from the mean, from the 0, isn't it? So if I did it properly, I would say the English is 1.8 above the mean, Maths is 2.5 above the mean, and Science is 1.76 above the, okay. So because it's my scores, I made it into all above the mean. It can go down, okay? Obviously, you will have a negative. So some scores may be, below the mean, okay? Of course, that's natural. So I can tell all 3 subjects I've done better with maths and English slightly better than science. In a nutshell, I can say Z-scores are used to compare raw scores, raw marks, from different distributions, for example, the different subjects, or could be some other things. So the main message here is Z-scores are very useful. So you might say, oh, what is this Z-scores? You may not use these Z-scores throughout your life, but just knowing that it's there, and you never know, you might use it one day. And this is wonderful, wonderful system here. Okay, so that sort of sums up a little bit about the formula we just used. So X is a raw score, mu is our mean, and sigma is our standard deviation. It just tells you how many standard deviations from the mean. And this is the what you can get from the reference sheet. Okay, so you don't really need to memorize it, but I think it's good to memorize. Okay, example 16. A data set is normally distributed, so it's normal distribution, with mean, so I'm just gonna put my mu equals 15, and standard deviation, my sigma, is 2. Okay, so it's important you collect all the information you need or you might need. And part A, draw the probability density function. So we need to do PDF, just normal distribution, okay? And then part B, use the Z-scores. That means we have to use the formula. Z equals, I'm sure you can remember now, raw marks, take away the mean, and then divided by the standard deviation, okay? So we want to find out each X values to the standardized scores, which means Z scores. When they talk about PDF, it's just a bell curve. That's all they're talking about. Mean was 15. My standard deviation was 2. So my 15 goes here. That's my middle. And then it goes up by 2, isn't it? So 17, 19, 21. And then go down by 2, 13, 11, and 9. That's it. That's all we had to do. Nothing special. Okay, now it's more action here. We're going to use the formula to find the Z-score, okay? When raw marks is 19 and 15 and 9. So first one, so Z equals, before I do that, I'm just going to put all the information I had. Mu, my mean was 15, and my standard deviation was 2, and my raw marks for this one is 19. Okay, so my raw marks is 19. Take away the mu is 15, and standard deviation is 2. Okay, so you put that in your calculator, you will get 2. So what does that mean? It means 19 is 2 standard deviations above the mean. I'm going to write that down here. So when we say above, but bell curve is just, it's nothing really above. It's just to the right. It just means to the right. So it's a 0 here, and 1, 2, 3. So it's here, right there. Okay, so to the right by 2 sort of thing, but we will say above and below, because in a real, I think, Z-score thing, when we're looking at, it's like this. It's a 0 here, 1, 2, and -1, -2. So when we look at your HSC results, this is what we look at. So it's like maths, you know, like extension. We'll get the point like here somewhere, something like that. So we know that it's going to be above the mean. And some year we go down below the mean. So that's why I think the word we're going to use is above and below. But, you know, technically we are moving to the right. And if it's a negative, we're moving to the left. X equals 15. My raw is 15. Aha, we can have a guess. Look at this. the mean is same as, the raw. So Z will be 0, wouldn't it? Okay, so, well, let's see. Z equals, obviously it is because raw marks and the mean is the same. So it doesn't really matter what standard deviation I have. It's going to be 0. This is because 15 is the mean. Next one, let's have a look. Now, raw score is 9. So Z equals 9 take away 15. I'll remember that. And divided by 2. I will get minus 3. Yes, because score is less than mean. So it's going to be negative. So it's going to be below the mean. Okay, which means it's going to the left from the mean. This is because 9 is 3. So that's 0, minus 1, minus 2, minus 3. So it's here, right? So 3 standard deviations below the mean. Okay, example 17. So a data set is normally distributed. Obviously, it's normal distribution we're going to use. And I am going to collect all the information that I need. The mean is the mu, 23.8. And standard deviation, sigma, equals 1.2. Okay, so I've got all the information I need. Find the Z score. So we have to use the formula. So I'm just going to put formula there. Each raw score. So that means this is just X. They're all X. Okay. All right. So that's what I have to do for part A. Part B, let's have a look at part B. Which of the scores from part A are very unlikely? Sort of like we're looking at the outlier, sort of, unusual. Part C, find the value of raw score. Okay, now we're looking at X when Z score is minus 1.82 and it's 2 decimal places. Okay, and of course we're going to use the mu is 23.8 and the standard deviation is 1.2. Okay, so my raw score mark is 25.7. Okay, so that's why it doesn't really matter what is a total score out of, because it never really gives you like it's anything raw marks is out of. Okay, so let's have a look. Z equals 25.7 take away 23.8 and all over 1.2 divided by that, and you will get, if you put that in your calculator, 1.58. So what does that really mean? Okay, I'm going to ask you a question because I don't know whether you actually here with me right now or somewhere else. Juliet, what does that really mean? 1.58.
I'm not really sure. I can't remember.
Joanne, if my raw score is 25.7 and my Z score is 1.58, what does that mean? The simplest way you can think about is picture it. So
how far the score is from the mean?
Pardon?
How far the score is from the mean?
Yes, that's it. So if we put 0 here, and my representation of the 25.7 on a Z score is 1. It's just halfway mark here, isn't it? That's my 1.58. It means 25.7 is what? Lies 1.58 standard deviations above the mean. At 25.7, the raw score lies 1.58 standard deviations above the mean. Okay, so to the right of the mean. So I want you to remember this sentence. So next one, my raw score is 20.6. Okay, I'm gonna convert this one to my z-score. So it'll be 20.6, my raw score, take away the average, the mean, 23.8. Oh, you can see it's going to be negative, isn't it? So it's going to be below the mean, and 1.2. You put that in your calculator, you will get 2.67. Now, what does that mean? Katie, what does that really mean?
It means that your score lies 2.67 standard deviations below the mean.
Okay, let's have a look at the next one. The raw marks 28.3. So let's put that in. Raw 28.3, take away mu 23.8 and divided by 1.2. Okay, so it's going to be positive, so it's above. It's going to be 3.7. Whoa, that's a lot, isn't it? If you think about it. Part of the 0.15%, because at the other end here it's this one. Okay, so they always have two tails. Wow, that's like 0.15% of the population that's got people will get the 28.3. Interesting. So Lorena, what does that mean? So my raw score 28.3 lies
3.75 above the mean. I mean
3.75 standard deviations above
the mean.
Excellent, thank you. Which of the scores, all the scores that we had, all three of them, like it's here right now, and it's in the z-scores, isn't it? Because that's our mean, the mu. Okay, very unlikely, very unlikely. So, okay, you might think, okay, so I can see 3.75 and minus 2.67 seems like, you know, one of them will be our pick. So let's check. Now I'm going to check the minus 2.67 from the mean and a little bit. Okay, so it's like a bit more than 2 standard deviations away from the mean, whereas 3.75 is 1, 2, already past the 3, standard deviations, and whatever that much. Okay, so obviously the further away from the mean are the extreme, isn't it? So we can say 3.75. Therefore, z-score of 3.75. You have to say z-score of 3. Because 3.75 is not your raw marks, isn't it? It's not raw score. So it is a z-score. So you need to say z-score of 3.75 is very unlikely. You're just using the same sentence from the question. So that means this raw score of 28.3, this means very high score. Okay, find the value of a raw score, making the x the subject when the z-score is minus 1.82. Z is minus 1.82. X we don't know. The mu was 23.8, and then divided by 1.2. X minus 23.8, and then you times this together, you will get minus 2.184, and then you plus 23.8 plus 23.8. Therefore, x equals 21.616. So my raw is 21.62 in 2 decimal places. I think that's all for today's lesson. Well done, people.